Hi everyone, this is Imran. This video is about seismic resistant building design assessment for the Skyfi Labs, and I'm going to describe about the response spectrum method and the time history analysis. The time history analysis is explained next to the response spectrum method. First we will consider the response spectrum method. So for this response spectrum method, first of all, we have to define the response spectrum function as per the IS 1893 2002. And for that, we have to go to the define and define the function response spectrum function. I have already defined the response spectrum function based upon the region of Bangalore and function damping ratio, and with respect to seismic zone factor, that is Z, with a soil type of a medium thing I considered as a type 2. And after the defining the function, we have to go to the define and we have to consider the load cases. We have to define a load case of response spectrum. And here in this seismic analysis, we do not consider the wind load effects. So instead of that, we make the response spectrum function. Next, we'll consider this for the two acceleration types U1 and U2. And the scale factor I calculated from the formula I into G divided by 2R, that is I have the value of 1633.5 as a scale factor. I considered that. Okay, then after we do not apply any load to the building, so we directly can go to the analyze and set loads to run. Here we will have the dead and live loads in the status of not to run, because we only consider the seismic and response spectrum. So next, after analysis, the first thing we have to do is the design check. For the concrete frame design, we have to first go to the view or revisor preference and then check the start design check, and we have to verify whether all the members have passed or not. For my case, all the members have been passed out. If not, you have to give an iterative thing. It will automatically improve the material section properties, section dimensions. Next, after the design completed, we have to review this, and we have to go to the display menu and stories response plots. As you can see here, we have to consider the display type to be maximum story drifts and the case combos to be seismic thing. Okay, and you can see here in this case, as per IS 1893 code, maximum story drift should not exceed 0.004 of the story height. The maximum drift we got here is 0.00061. When I calculated, multiplied with the stories of 12, and I got 0. Which is in the permissible thing. In this case, we can see that the story drift values are within the permissible limit. Similarly, change the case combo option to the response spectrum to other cases like the model thing to view the model analysis. We can see two different lines on the graph because we defined two loads earlier while defining the response spectrum function. Okay, after this response spectrum analysis, you can also go through the force stress diagrams, anything you want. This is in a moment 2-2 diagram. This is a shear force diagram. Like this, you can go to any of these and check it out. After this, now we will go to the time history analysis. So close this file, save changes if any, and I'm going to open my file which is separately made for the time history analysis. Time history analysis assessment project completed. Okay, this one. When I open this, the method of seismic resistant analysis for a building is changes. The entire procedure is same. First we will define anything, we will then assign it, analyze it, and finally design it. We will review the graphs. So here in case I already analyzed, you can see here the lock screen. That means I have already analyzed it for different set load cases, that is except dead and live. I have run the analysis for seismic and time history final. Then now we will check the time history plots which will give a results that I have carried out the analysis. And go to the display, and we will go to the display menu and plot functions option. Here we can see that response due to the seismic waves on the building model based on the time history data with the help of a graph, where the reference file is considered from Buzz earthquake occurred in 2001. At the bottom we can see the time required to get the maximum and minimum base reaction values. Now we will go to the display menu. We will go to the combined story response plots. For this time history analysis, we can see the displacement, drift, shear, overturning, everything. There are various effects of seismic waves with the help of these graphs. As per IS 1893 code, the maximum story drift value we know should not be greater than the 0.004 times of the story height. So the maximum story drift is within the permissible limit. And we also have an option of animate, where we can see here the graphs and the variation which is in permissible limit. Finally, we'll exit this, and after the review of these plots, we can consider display and the force stress diagrams for this also, frames and the moment diagrams. If we apply to this, we can see here these are the moment diagram. This is shear 3 of 3 section, this is shear of 2 of 2 section, this is moment of 2 of 2. Like this we can consider any of these. Now coming to the display, select the undeformed shape. We will have the visible shape of a building. If you consider a rendered view, the building will look like this. Thank you very much. Thank you for your patience. I have discussed in this video the two methods of seismic resistant building design, that is the time history analysis and response spectrum method. The time history analysis is useful when it is having a prior record of data of earthquakes where there is a frequent occurrence of a considerable amount of earthquakes range. And response spectrum method is considered for the accurate or the peak values. Thank you very much. Thank you for your patience. Thank you.